All right, let's go ahead and get started. How y'all doing today? Good, bad? Okay, so one thing, my microphone is running out of batteries. If you all noticed sometime during the lecture that the batteries have run out and you can no longer hear me, will you let me know? And then I will stand next to the computer and change it so that my voice will actually get recorded for the video, okay? So if you need to watch it again. All right, any questions about the project? How's everyone doing? Yes, sir. Yes, if you find something, a subject that's not able to match a subject, that you output that. However, for some reason, and I don't know how this got started or how it got passed around, everybody seems to be trying to input two non-matching files, right? It's like you choose the Almaty subjects file and then like the burn side effects file, and then everybody's like, I get weird results. Of course you get weird results because that is not how the program is intended to be used, right? The babies from the Almaty group don't go, or the subjects from the Almaty group don't go with the side effects of the burn group. They just don't. I'm not going to test your code that way. And in fact, if that unable to show subject ID shows up, then something has probably gone wrong somewhere, because the subject IDs in the side effects file do match the subjects file, okay? You don't have to test on non-matching files. You can if you want, and some people have found that they have uninitialized variables from doing that, right? But I'm not going to test your code that way because it just doesn't make sense. Right? The purpose of unable to match is to catch an error, right? I'm just saying that the way we're using these files, you should not be encountering errors. Okay. Other questions? Yes, sir. So, okay, so there is one function that does average for group and one function that does standard deviation for group. And it takes a couple of parameters. Whether you're talking, for that one, it takes whether you're talking about the control group or experimental group. And it takes whether you're talking about headache, stool factor, or cough. Was that the other one we had for this assignment? So one of those three things, right? And it will compute the average for that. I actually answered this on Piazza. So if you need to refer to Piazza, there's like a written explanation of this. So it turns out that there are like 6 different averages, right? Control and experimental versus times cough, headache, and stool, right? So there's 6 different ones. The code for each one is really similar. Like it's really, really similar. All you do is you loop through the subjects if they are the experimental control that you're looking for, and then you can go ahead and process them, and then you just use the cough, stool, or headache factor to pull out the correct thing, and then you add it together, right? So rather than writing 6 different functions, each one of which already has pre-coded whether it's control or experimental, and pre-coded whether it's cough, stool, or headache, you write one function that takes those as parameters. The reason we do this is because if there's one function, there's less chance of us making a bug, if we're making a mistake. And if we do make a mistake, we only have to fix it in one place. If we write 6 functions, each of which does that, then there isn't a chance that we will make a mistake. And if we make a mistake, we'll probably only fix it in that one function and won't remember to fix the other 5 that we mostly cut and pasted. So then the analyze functions, all they do, each one of them is like 2 lines long. They call the average for group and they call the standard deviation for group after computing the average, but they put in the right parameters that the analysis needs to do. Okay, does that make sense? Other questions? How many are you almost done or about done? Okay, question? Oh, the integers for the load files just return the count of the number of things loaded. Okay, and that's a habit that I have just because then you can do some error checking to see if you actually loaded anything or not from the other function. Yeah? Yeah, sure. I mean, we already know how to do like that thing, right? Sure, why not? Knock yourself out. I'm not going to take off for it. So I'm trying to, for each of these projects, for the most part, I'm trying to like focus on the new stuff and not make you redo the old stuff over and over again, other than typing like 14 different variable names, right? Like maybe I'll just put a question on the exam. What were the 14 different variable names? How many of y'all think you could list them all off the top of your head? Yeah, most of you now because you've typed them like 1,000 times, right? So So I'm trying not to make you do the same thing over again, so we're not going to require that. We already made you do it once, right? Can you do it again? How many of y'all would like to go back and do project 1 again instead of project 5? How easy would it be? How easy would it be? Ridiculously easy at this point, right? So, and just wait, someday all this stuff we're doing now will also be ridiculously easy. You just have to keep practicing, okay? Don't look at me so skeptically, it's true. Like, no way. So, okay. Any other questions before we get started on new stuff? Everybody happy today? How many of y'all are going to be here on Wednesday? Oh, good. Okay. So, all right. So before we get started, last time we talked about a bunch of stuff that I seemed to repeat over and over again, didn't I? Let's repeat it some more. Why are we repeating it more? Because repeating things is how you learn, right? Spaced repetition. So we're going to review. All right. So for a piece of candy, what is this? Who said that first? Sorry. And by the way, this is the last of the candy. We've gone through 10 pounds of candy in this class. About 7 pounds of that is on my body now, so I'll get rid of this. Okay. Ampersand. Do y'all remember the ampersand? What do we use the ampersand for? And there's a hint. There are 2 things. Who wants to answer the first? Yes? We use them for reference parameters, right? And thank you for choosing the one that was in the order of my slides. I appreciate that. Oh, a little low there, sorry. Okay, reference parameter. Here is an example of a reference parameter. We have one function, get, average, and standard deviation, and it needs to return 2 values, right? It needs to compute 2 values and pass them back. Can we pass 2 things back by using the return statement? We cannot, so what do we have to do instead? We use this ampersand for reference parameters, okay? Anything that happens inside that function to one of those parameters will persist, right? When you go back where that function was called from, those changes will still have been made, okay? Unlike not having the ampersand there. If we don't have the ampersand there, they're called what parameters? Value, and they get copied over, right? And if you make changes to your value parameters, it doesn't affect anywhere else. All right. What is the other thing we use it for? Yeah, Flannery. The address operator. What is the address operator? It finds the address of something that has a name. Very good answer. So it finds the address of something that has a name. So in practice, we almost never do this, right? As we write our programs, we don't really use the address operator. But we're talking about it here just to help you understand what it does, okay? Because if we started talking about addresses without it, it would be confusing. So instead of using the ampersand to get the address of things that have names, instead we are going to use pointers to make things that do not have names. Okay? And so we won't have to name things. So here is kind of one way that we looked at doing this. We declare an int x, we set it equal to 6, and then all we have to do is say cout ampersand of x, and what is that going to output? And what will that be? Yeah, but what hexadecimal value will it be? You don't know? Why don't you know? Because it's going to turn out different each time. Like what this ampersand x, what the address of x turns out to be, is going to vary almost on every single run of the program, because each time the computer will choose a different address to put it in. Okay? It won't always be the same address. In fact, it's unlikely to be there. Okay. What is this thing? A star. What is it used for? 2 things. It's used for 2 things. Like the ampersand is used for 2 things, the star is used for 2 things. What is the first thing that the star is used for? Raise your hand if you like to. Ian. Dereferencing an address, absolutely. Yeah, good job ducking Chris here. All right, dereferencing an address. What does it mean to dereference an address? Yeah? Uh-huh. Exactly. You go to an address. When you dereference the address, you go to that address. And when you get there, you work on whatever's there, right? So if we have an integer, if you dereference an address of an integer, you have an integer and you can work with that integer directly. Okay, so here's an example, right? We said x equals 6 before. We see out the address of x, and what is this going to be? What hexadecimal number? We don't know, right? We don't know. But it's going to be some hexadecimal number. It's going to vary every time. If we do star x, what does this mean? Go to the address, and when you get there, what do? Change it to 12. So when we see out and x, what are we going to get? What? Yeah, the address, but that's not what I meant to do, sorry. Just checking. Let's do this instead. All right, when we do this instead, what's going to happen? What's this going to output? 12, right? It says we go to the address, we go to x, oh man, I totally screwed this example up. Sorry about that. I was in a hurry this morning and I was cutting and pasting. Ah! That's really screwed up. Okay. That's much better. Because we have to actually dereference the address, put an address to dereference. Okay. So that makes more sense to me. Make more sense to you or less sense? Good, thank you. You should tell me if I'm doing something wrong. Okay. So the one thing that we have to do is dereference an address. So if we have an address and we know ampersand x is address, we dereference it, we go there, and it was 12, and if we see out that way, we get 12. Would it matter if we did star ampersand or if we just had an x there in that last C outline? It would be 12 either way. Yep. It would be exactly the same thing. Both of these things work in the same way. So you can think of if ampersand is the address operator, like star is the unaddress operator, right? Why am I doing it this way? To show you these operators to try and refresh your mind and to confuse you as much as humanly possible so that I'm able to give you a bad grade on the exam, which we all know is why professors live, right? That's what we live for. No, I'm just trying to show you these operators to refresh your mind. We won't use them this way, okay? Instead, we use them a different way. So what's the other thing a star can do? Yep. The other thing, it can use it to store an address. Okay? You can use it to store an address. The way we do this is like this, right? If int x equals 6, this is the type of thing we're used to seeing, right? We declare a variable. Then int star means what? Int star means it's the address of something that holds an integer. And in this case, we're calling it address, and we're setting equal to ampersand x. What's ampersand do? The address. So if we printed out what was in address, what would be in there? Like if we did C out address, what would be inside address? And what would that look like? What hexadecimal number? We don't know, because it will vary from time to time, but this will be a hexadecimal number, and if we dereference it, we will be working with the thing at x. So there we have stored an address, and we've designated it as an address by putting a star in front of it. Okay. How do we dereference a stored address? Yep. Yes. You put the star in front of the variable, and I said thing here, but variable would be a better word, that was defined with the star. Okay? So we defined something with the star that meant it was an address, and then we used the star to dereference that address. This part's confusing, right? It is confusing to keep track of what star does what and what ampersand was there. How can you tell the two stars apart? Yep. Okay, you can look and see if there's a type before the star, and if there is a type before the star, that means what? That you are creating something that will store an address, and if there is not a type, then you are dereferencing an address. Okay? All right, so here's a little bit more of our code here. We say int x equals 6. We say int star, which means it's going to be the address of something you hold an int, equals ampersand x, so it gets the address of x. If we say star address equals 12, what happens? It changes what? What's at the address? So what is currently at the address if we do star address? And then we set it equal to, so what's at star address after that? 12, yep. And then we see out x, and what is x when we see out it? How many of you think it's 12? How many of you think it's 6? Anybody think it's 6? Okay, it's 12. So seeing out x and seeing out star address both produce 12, right? Both of those things produce 12. All right. Okay, so star address means deref address is a value that can hold an address. Maybe this is confusing. So we have a variable named address, right? What type is address? It is sort of an integer, but what does the star make it? The address of an integer. So this thing address can hold the address, because the star is there, of an integer. Then we actually assign it to an address. What address do we assign it to? The address of x. So when we have star address, is it the same thing as x? Yeah, it is. You sound skeptical, but it is, right? Because we say, okay, this thing has an address. If we say star x, it means go to the address. And what do we know is at that address? X. And we happen to know x is 6. Okay? So then when we see out x, we'll get 12. And if we do star address, we will get 12. Right? If I say go to x, if I say go to the box named x, you can go there. If I say go to the thing, the address that is stored in address, you will end up at the same box x is in. Remember last class we talked about delivering pizzas? We said one of the ways you could do is you could go talk to Dean, and Dean knew where to deliver the pizza. This is exactly that, right? The thing address knows where x is stored, and if you go to the thing that's in there, you will end up in x. One thing I'm not sure I covered last time, how do you initialize an address? And the reason we know we say that is we know if we don't initialize it, then we don't know what's in there, right? If we don't initialize an integer, what value is in that integer? If you don't initialize the address of an integer, what value is in there? We don't know. It could be 0. We would like it to be 0, but it may not be 0. It may be some other value that's pointing somewhere, and it will mislead you. So how do we initialize it? So there's two ways. I'll just show you both at the same time. You can use this keyword null, N-U-L-L, or you can use 0. I would encourage you to use null, given the choice between the two. I know I'm lazy, I know I don't like typing, and I know that null has like 3 more key presses than 0 does. But when people are reading your code, it stands out when you use null. And somebody will look at it and go, oh, the only thing that can really be null is a pointer. So now I kind of realize that you're using a pointer. Whereas if you use 0, could it also be an int or a double or a character or a string? So I guess null could be a string, but it doesn't have quotes around it. So I would encourage you to use null. So when you create an address, you can use null. And we'll get some examples of that today. How do we create a variable that has an address but that has no name? Yep, we use this new function. And the way new works is you say new, and then in parentheses, what type of thing you want. So for example, we could do this. We could say int star x equals new int. Okay, let's break this down. What is x? It's a variable, and what does it store? The address of an integer. What does the new int give us? It gives us a box. What is the name of the box that new gives us? It does not have a name. What does it have? An address, and where does that address get stored? In x. So now we have int star x. That box x holds the address of another box someplace else. What if we printed out X, what would it say? If we did C out X, right, after we did this first line of code, what would we see? A what? An address, and what would that look like? A big hexadecimal value, and what value would that be? We don't know, and we don't care, right? It's just some value that there's an address, but we know if we go there, there's an integer. So we say star X. What does star mean in this context? It means dereference. How do you know it's dereference? Because it doesn't have a type in front of it. It means we're dereferencing X, and we're setting equal to 12. So this whole thing means dereference X, or go to the address, and when you get there, put 12 in that box. Yep. Mm-hmm. Okay, so the question was, we can make a box that has no name, but we still need an address that has a name to be able to track down where that box is. And how does that help us? And so how does it help with the problem of having to create item stores? We're going to look at that in great detail over the next several classes. Okay? So, and this is why this is the good stuff. Okay, we get to the good stuff here. All right, and now we can see out star X. What is this going to give us? How do you know? Because you're dereferencing. How do you know this is a dereference? Doesn't have a type in front of it. Okay? I'm trying to drill into these rules, right? So that when you're looking at code on the exam, you will not get confused. You can at least look and go, oh my God, I see a star. There are two things a star can be. Actually, three if you include multiplication. But two things a star can be in terms of pointers, and so I know it's 2 sets. Okay. So we don't have to just use, we don't just have to use ints, right? We can actually use anything we want. We can have a pointer to anything. And if we wanted for our current project to have a pointer to a subject, we could say subject star mom. See this star here? What does this one mean? Is this one dereferencing or is it declaring a variable? How do you know? There's a type in front of it. What does this type happen to be? A class that we have defined. What is a class? A blueprint. And what is an object? Thing that's built from that blueprint. So we say subject star mom, which means mom is going to hold an address of a subject is equal to a new subject. So what does new subject do? Creates a new subject. What is the name of the subject? What is the name of the subject? Doesn't have a name. All it has is an address. How do we find the subject? If we want to get to it, we dereference mom. So we can do something like star mom.report. Okay? Star mom.report. Does that look a little bit confusing to you? Yes, it does. So let's look at that in detail. Okay? We're looking at star mom.report. So let me tell you how to break it down. So the first thing is mom. What is mom? No, literally, what is mom? It's a variable, right? And what type is that variable? It's the address of what? Address of a subject. You don't just have an address, you almost always have an address that of something, like address of an int or address of type. So we know mom is go to the variable mom and get the value in it, right? And we know the value in it is actually the address of a subject. Okay, so the first part of reading this is go, oh, mom. That's a variable, it's an address. What part do you think is next? Pardon? We just dealt with the mom part, so we have a star and we have a dot report. Star. So the star means dereference that variable, right? So we know that mom is an address, and if we dereference that address, we end up at a box. What is in that box? It's a subject, all right? If we just have the variable, we know it's an address. We don't know what value it is. But if we dereference the address, we know that we are working with a subject object. Okay? So now we have a subject object. So star mom means dereference the variable. Now you have a subject object. What can you do with subject objects? You can call the methods on them. So if we do dash report, if we add a dash report to that, it means call the report method on that subject. Okay? So we start with mom. We know that's an address because we saw the definition. Like the definition we knew was a subject star, so it was the address. We dereferenced it, which gave us a subject. And then after we dereferenced it, we could call the report method on that subject. Everybody with me so far? Who's with me? Who's against me? Who's unsure how they're feeling right now? Who wishes it was Thanksgiving already? All right, questions about this? Any questions? I'm trying to explain it as clearly as I can, but if you can tell me what is weird, I can try and explain it a different way. Yes? Yep. Remember, we created the new subject on the last slide. So we said new mom equals new subject. And when we said new subject, it actually creates the subject and puts it there. Yep. Yeah, the one where this one? Mm-hmm. New subject says we are making a new subject object. Doesn't have a name. Whatever's inside of it is whatever's in the constructor that's called. And so in the subject class, there should be a default constructor that's like subject : subject that does whatever. So if you have a default constructor in there that's subject : subject with 2 parentheses and nothing inside, that is what will get called in there. If you don't have that constructor, you can add the parentheses and whatever values inside that, and it will work. Okay.
How is it like a blueprint or class has a lot of variables?
Mm-hmm.
So does it mean that they have a lot of address?
So you want to know the magic behind how the subject is actually laid out across a bunch of boxes, so that because there's a bunch of other variables inside of it. Yeah, too bad. You'll learn that some other time. Okay. No, I admire your curiosity. It's just beyond the scope of this course to talk about how it's laid out. But I can generally tell you that they're laid out contiguously. Like, you know, if you had a subject that had age factor, age would be the first one, age factor would be the second, and so on. And then they would all be clumped together as one thing. But we're hiding a little bit of that complexity now. Okay. All right, how's everyone doing? Okay, so the question is, and I would like to, Claire, right? Was that your name? Good. I would like to get back to Claire's question, which is, how do we actually use these things, right? Because we have things with a name, but we're trying to reference things that don't have a name. And if we have a problem that, like, if we had 100 of these things, we wouldn't want to have 100 names. Here, what we're seeing is that we still have to have a name that points to every single thing, right? So how do we deal with this? And the answer is, we're going to use what are called self-referential objects. And I got into that a little bit last time, and I drew a really, really bad diagram. I installed some diagram software on my computer, so as we go on today, we can make better pictures more quickly. But we point to a self-referential object. And a self-referential object is an object that has a pointer to another one of itself. Okay? Yep. Something of the same class or type. Right? So we'll make an example right now after we stand up for a minute, because I just talked for half an hour straight. Stand up. Everybody stand up. Stretch for a minute. All right, welcome back. Feeling better? Y'all shouldn't have let me talk for half an hour. You should have been like, Clay, shut up. Let's stand up. All right, so here's what we're going to talk about now. We're going to talk about these self-referential data structures. Self-referential data structures are data structures that have a pointer to a copy, another copy of the same thing that they are. Okay? So our example is going to be the node class, and we're just going to call these things nodes, and we will link a whole bunch of nodes together. And our node class is going to have two things inside of it: an integer, which we can call the data, and it's going to have a pointer to another node. How do we define a pointer to another node? How do we declare the address, store the address of a node? God, you all are awesome. Node star, and we're going to call this one just next, okay? This is going to be the next thing. In fact, let's call it next node just to be very clear about what we have, okay? So one of these things is going to have some data, and it's going to have another pointer to another node. Right? Now, if we're going to have these things, we need some methods to access them. What kind of methods do we need? Some get and set. So we can be like get data, and what's that going to return? An int, because we're just doing the data portion. We're trying to get the data portion, not the other portion. We're going to have to, what other thing do we have to get? Okay, so we're going to have to get the next node. And what kind of value is this going to return? What's this going to return? It's going to return a node, the address of a node. The next node is not going to be node, it's going to be the address where you can find the next node. Okay. Nope. Because we have two private, we have some data that's going to be an int, and we're going to have a pointer to the next node in the chain. So let me describe briefly, let me give you something conceptually before we talk about this. I'll do this now instead of later. Let's say one day you go out fishing. Anybody ever been fishing? Go out in a boat, go fishing. What's it like when you go out fishing? What? It's boring? So what do you bring along with you? And food and what? Drink, or if you're of age, beer or soda or something, something to drink, right? What did you say? Friends, right? You bring friends and you bring some drinks. We can talk about doing what I'm about to say with your friends later. We'll see if it's appropriate or not, okay? But so you go out on the boat and it turns out that you forgot the ice. That's sad, right? But you have all your drinks with you, right? What do you all enjoy drinking? Water, because nobody drinks Coke anymore because it's sugary, right? So you have like a big case of water and plastic things, plastic bottles of water, right? Except you're environmentally conscious and have your own bottle of water, but let's just skip that. We brought along like cheap throwaway ones. Okay, everybody with me? So we have this big case of water, and we want to keep it cool. How do we keep it cool? We don't have any ice. We forgot the ice. Put it where? The shade is cool. What's cooler than the shade? The water. That's a good idea. So how do we put our bottles in the water? You what? You hang them off the side of the boat with what? With some fishing line, because you have fishing line, right? So here's what you do. You take some fishing line and you tie it to a bottle, and then you throw the bottle overboard and you tie the line to your boat. And now you have one bottle in the water and it's nice and cool, right? Well, here's what we're going to do. Pardon? Please bear with me for the sake of analogy. We'll pretend this is a short story, willing suspension of disbelief, right? So here's what you're going to do. You're going to take a string and you're going to tie a string to the bottle and you're going to throw the bottle overboard and you're going to tie the string to your boat. And so now you have a bottle of whatever beverage you choose in the water and it's getting cool. But you have like 20 other bottles, so what are you going to do? Well, you can put them all together in a line. You put a space on the next one and you tie it to the first bottle, you tie the second bottle to the third bottle to the fourth bottle, and so on. So in the end, you have one string that's tied to the boat. How do you get bottles if you want? You pull on the string. How do you get to the last bottle? You pull on the string until you get to the first bottle, and pull on that string to the second, pull on that string to the third. Okay, do you all kind of have a mental image of this? We have a thing that's the water bottle, and we have a string that goes to the next water bottle. In my example, the water bottle is the thing that holds data, like the int. The string is the pointer that leads to the next water bottle. Okay? So we're going to have all these things linked together one after the other. Everybody with me on that? The other place I've seen this done is when I was in the Army. People would hide things they weren't allowed to have in the barracks. And the way they would hide them is they would lift up the false ceiling and they would drop things down inside the wall, because the wall is actually hollow most of the time if you have cinder blocks or stuff. And what they would do is they would tie all these things to a string, and they'd lower in one after the other, and they'd have one string tied to the top of the wall. And if they wanted to get out the thing that they were supposed to be hiding, they would reach up on the wall and pull out the first string and then pull it up to the second all the way down. But not many of you have been in the Army. I guess not many of you have been fishing either. So, all right, so you're going to tie everything together and throw these overboard. Is that something, Emma, you would have liked to have done with your friends? Tied string to them and throw them overboard after linking them all together? So, and that's why we don't go fishing, okay, with you. Okay. All right, so everybody sort of have this conceptual idea of what we're doing? We have 20 things tied together, but how many strings do we actually have to find them? We have one tied off. And if we want to find the thing, we have to pull on that string and then find the bottle and find the next bottle and so on. That's sort of what we're doing here. We're going to have a pointer, a named pointer to the first node, but to find the next node, we're going to have to look at the pointer inside and follow all the way along. And if you ever come up with a better analogy for this, please let me know. This is what I've been using for years. Do you have another one?
Just like children on child leashes.
Yes, children on child leashes, like on daycare where they have like one rope and they're all... Yep. All right, maybe I'll use that one next year. So we'll see. All right, yeah. Sure, of course we have to initialize next node. And we have to initialize our data too, but where do we initialize things? What? How many of you said int main? I heard people say int main. Where? In the constructor. The constructor will initialize these values. So we need a constructor then, don't we? Because we have a couple of get data, but we also need a constructor. How do we define a constructor? What does that look like? Just say what? Node, okay. And we'll make a constructor. Okay, so if we get data, do we also need to set data? So we can do set data. What type is this? This function? Void, yep, because it doesn't return anything. But we have to set an int. And we also have to set next node. And what are we going to give set next node as an argument? If we set next node, what are we going to set it to? What? Nope. What type is node here? What type is this? No, it's not an int. Next node right here. It's the address of what? It's the address of a node. It is not a node. It has the star, so it's the address of a node. So what we have to say is we're going to give this the address of a node. Okay? All right, people are baffled. So let me try drawing a little picture. And hopefully this will go a little faster. All right, so here's my drawing program. I know, it's amazing, isn't it? So here's what we're going to have. All right, we're going to have a thing that is a pointer. And we're going to give it some name, and it's going to look something like this. We're going to say node star, but that's pretty small, isn't it? Maybe I can zoom in. Is that better? So we're going to have a node star, and that's going to be a pointer to something. I don't think I need these right now. Okay? So we're going to have a pointer to something. What does a node look like? It is, but we have node is what? It's a type, it's a class. What is a class? A blueprint for an object, right? So what things are inside this node class? We have two of them. An int and Yep, an int and address. So here's the way I'm going to draw these things. I'm going to use this little box like that. And this top part right here, we can put a number in. And then we're going to represent the address by an arrow. Okay? We're going to represent the address by an arrow. Why are we going to represent the address by an arrow? Why don't we just put a big hexadecimal number in here? Because we don't know what the address is going to be, right? All we know is an address. Remember like 20 minutes ago when I said over and over again, what's in there? An address. And I said, what address? And you said, we don't know because it gets assigned by the computer when the program runs. So we're just going to use arrows for these addresses, okay? So we're going to have one thing over here, which is going to be a node star, which is the address of a node. And this is going to be the first node on our list. This is going to be the first bottle that was thrown overboard from the boat. And this string right here, this node star, is the first string that is tied to the first bottle. It is the string that's attached to the teacher from the first child for all the children who are walking along holding hands. Okay? It is the first hand. I like that analogy a little bit better. Maybe I'll use that next year. Everybody with me? Yes? And what we're going to do is we're going to have other nodes. So for example, we can create another node and put it over here. What number is going to be inside this one? Make up a number. What's your favorite integer? 11. So each one of these nodes is going to all kind of be linked together, one after the other, until we get to the end. And when we get to the end, we will have a node that doesn't link to anything. And the way I draw nodes that don't link to anything is with this little ground symbol. So you can just say, when you see that, that's like an address of 0. It just doesn't link to anything else. That's like the end of our chain. And what value is this one going to have inside here? What integer would you like in there? What? 4? Okay. So this is what we're going to be working towards, okay? Just like we had strings attached to bottles, and each bottle was attached by a string to the next bottle, we're going to have a node. The thing with the name we're going to have is going to be this node star. It'll be like the first string. And then we will have one thing attached to a string, attached to another, attached to another. And the next node pointer, this thing right here, is what keeps track of all these things. Yep. We haven't done the attachment yet. I'll show you. I'm sort of going back and forth between the code and the picture. So, does this answer your question? Now we have one thing with a head, and we have an infinite number of things linked together. So we only need one name now to keep track of a large number of other things. Okay, yeah? How do you think they build vectors? Remember, vectors were magic. And I told you we were doing away with most of the magic. Vectors are just pointers inside. Which gets us to Project 5. Actually, in passing, Project 5 will be similar to Project 4, except you will not be allowed to use vectors. You'll be using pointers. Yep. Yeah. Yep. Just like we had subjects. Remember we talked about having subjects? We could have a pointer to a subject. A subject has what 14 things inside of it? Age factor, yada, 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 right? What we're saying here is that a node is very much like a subject is going to be, except instead of having 14 things, we only have one thing inside there. And we have one added piece of data, which is, where do I find the next thing along? Why do you look so happy? Yeah. Uh-huh. Uh-huh. Yeah, and so the question was, so you can't hear on the video, is in order to get to like node 4, you can't just get to node 4. You have to go to node 7, look up where the next one is, go to the node that contains 11, get the pointer, and then you end up at node 4. So you have to do what's called traversing the list all the way down. Oh, and by the way, this has actually a name for it, and this is called a linked list. All right, so here's our linked list. All right, everybody sort of have an idea where we're going now? You all have, like, I don't ever want to play poker with you all. It's like, how many of you all see where we're going? How many of you all have arm injuries? How many of you don't see where we're going? Any questions on this? Yeah.
So, in referencing to our project, each of those boxes are going to have all the things of the class.
So when we get to doing this in the project, we're not just going to have one integer. We're going to have a bunch of variables in there. But the concept is the same. There will be one address that points to the next thing. Okay. Yeah, I'm gonna bulk order a bunch of masks from Amazon that have big smiles and just make you wear those so that I have some feedback on what's going on. You're all looking at me like I'm crazy or something. Okay, so this is the code that's going to do what we said, right? Remember, we have a node, and a node is one of these objects that has a number and a pointer. We have to be able to get the data and get the next node in and out of this object, and we have to be able to set the data and set the next node. So here, this 7 is going to be the integer portion, the private data member of a node, and this thing down here will be the address of the next node. We are indicating that as an arrow rather than trying to print some incomprehensible hexadecimal value that we don't even know what it is. Okay? You're making me nervous, man. What? Yeah. Okay. Okay, so we have these different methods. This is everything we need, right? We have a constructor, we have these other things. Let's build some of these. How do we build a constructor for this? Oh, sorry, I'm using lowercase, not uppercase. Okay. Node, : node. Put some parentheses there. What should we set inside here? Okay, what do you want to set it to? And what else do we have to set? Anything else? We definitely need to set next node. If you do not set next node, you will get in trouble because next node may point randomly someplace that you can't even see. So how do we set next node? Yep, null is better. Okay, let me just start doing some compiling here to see if I'm making any horrible mistakes. Ah, shoot, I was afraid of. Okay, I think this has to be uppercase. There we go, yeah. So null has to be uppercase in C++. Other languages don't require that. All right, so when a node is created, what's going to happen is the data will be set to 0, and the next node, the pointer will be set to null, meaning it is not pointing at anything. All right? So what else do we have to set? We have some other things. Here, split this way. So we've defined node, we've defined the constructor. What do we have to do for get data? Okay, looks good. What else? I have to what? Oh, you didn't tell me that. What else do you want to have to put in there then? Uh-huh. Uh-huh. Oh, thank you. Yep. All right. So this will get data. We also have to return next node. How do we do that? Yep, we're going to be giving back the address of a node. That's what we're returning. It's part of the node class. And it is get next node. Oops. And what do we do here? That's it. Okay. What else do we have to do? We have to be able to set these things. How do we set them? set data. Just that. And then void node, get data. And this, oh wait, it's not void, sorry. Oh, set, that's what I'm doing. This is tedious, isn't it? We have to get to the address of a node, and it's going to be X as well. Eventually I'll show you the shorthand way of doing this, which is actually a lot easier, but for right now we'll do it the next way. Okay. Next node equals X. Do we need a star in front of there? Why not? Because they're both addresses, and we are not yet dereferencing any addresses. Okay. All right, so we've created our class. Now we can actually start doing things. So here's what we do. We have node star, and this is going to be the single named variable that we have to keep track of everything. What do you want to call this? How about we call it head? Because head is the traditional name for this thing right here. Okay, so the head of the list is this pointer that points to the first node, and we often call that head. Okay, so we have a named variable. We have a named variable named head that is nothing but an address of the place you can find the first node. Okay, everybody with me? All right, so let's make a new node, and let's try to make it like our picture. So we're going to have a new node there. How do we do that? We do have to call the constructor, but is this thing going? Is this node right here that has the 7 inside of it? Does that have a name? It doesn't. What does it have? How do we get something that has an address? Star is how we declare it. Star is how we dereference it. How do we actually create one of these things and define it? New, exactly. So what we have to do is say head equals new node. Let's make sure that compiles. Yep. So what we're doing is saying head equals new node. So we have this address, we're pointing at something, and we said head equals new node. What is inside this node when we create it? Pardon? Oh, but you do know. When we create this new node, it calls the constructor, so it sets the data equals 0, and it sets the next node equal to null. Okay? Yeah. Yes, it does. So what we've done at this line right here is essentially we have created this thing and this thing right here, but not those. And that's 0 right now. So let me redo that. And right now we have this. This is 0, and this thing, actually, this pointer is null. It's pointing down. It should be pointing down at the ground. Okay. So at this point in time, we have. Hang on a sec. We have this. We'll get rid of that one. So right after these two lines of code, we have node head, and it's pointing at a node that doesn't have a name, but it has 0, and it's not pointing to any other value. Okay? Because the way the constructor works, it says make data 0 and make next node null. So now head is null, and then, I'm sorry, head is initially null, and then it points at a new node. When you call new node, it calls the node constructor, which sets everything to 0. And we end up looking just like this. Node head points at a node that doesn't point at anything. Okay? Yep. It is the address of a node. It is not a node itself. Head is the address of a node. That's why this star is there. Because this thing over here is actually a node. And what's happening is new node creates this particular node, and it stores the address of that node in the variable head, so we know where it is. So head is the string that's tied to the boat. Head is the teacher's arm that's holding on to the linked group of children behind you, right? That's what it is. But it is not itself a node. It just says, where do I find the very first one? Yep. Why don't we give this thing here a name instead of an address? How would you have an empty list? You can't. You would always have to have at least one thing on your list. And here, if this first pointer is null instead of pointing at something, that means we have an empty list of 0 things. Yep. Yep. Mm-hmm. Yep. Okay. So if we had head equals new int, if we had node star head equals new int, we would get a compiler error. And the reason we would get a compiler error is that we have to keep track for every address of what type of thing we expect to find at that address. So if you said head equals new int, it would say this node, this address of a node actually points at int, and the compiler would go, no, 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 wait a sec. Can't do that. But I mean, I'm trying to figure out how to describe it. It's just, this is literally a value. It's a big hexadecimal value, right? 0x77 blah, 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 like we had. We're just drawing this as an arrow because we never can really predict what that address is going to be. And conceptually, we don't really care. All we know is that if we dereference that, meaning we go to the end of it, we find an object of the right kind when we get there. Does that sort of help? I know this is like totally baffling at first. In fact, this was like the first computer science concept I ever had to teach anyone in my life. And have you noticed that we've done, like, we spent an entire class repeating the same terms over and over and over, almost, and then half of this class, and you're sick of it right now? But the reason is just we have to understand these basic things. So if you have the address of something, you don't actually have the thing. You just know where to go to get it. If we dereference the address, in which case we're dereferencing head, we actually get the thing that's at that address, which is going to be an actual object or variable. Right? If I said go to 323 St. Mary's and talk to the professor there, what's the address that you're working with? 333 St. Mary's. Who's actually in that office? Some professor. So 333 St. Mary's is the address, and the actual professor is the professor at that address. Actually, I said 23 because that's my office, right? And if you went there now, there wouldn't be anything there because I'm here, but if you went to that address, you would find me. So if we had Professor Star, that would be the address of a professor, and that could be 323 St. Mary's. But when you got there, you would find an actual office with a professor inside. But you would actually have to go to that address. So we have addresses, and we have actually things that are at that address. All right, if you're not confused, how many of you are terrified? Anybody? A few of you? Yeah. So this takes practice, right? And it gets a little confusing, and things go wrong sometimes. Okay, so let's switch back to our code. Here's what we've done so far. We said we're going to have the address of something that's set to null, which means we have an address, but we haven't actually told it anything. So let me just say that I have this piece of paper. In a few minutes, I'm going to write an address of a professor on it, and if you looked at this address, you could go to the professor's office, but right now there's nothing written on it. Okay? Does that analogy help? So we're going to have an address, but we don't know what it is. Then we say, okay, we're going to set that to something, and the thing we're going to set it to is a new node. The new keyword creates a brand new node. It springs into existence. It runs its constructor because when new things appear, they run their constructors. And it sets the data in the next node to 0. And then the address of this thing that was just created someplace is stored right there. So we end up with the picture like this. This is the pointer. This pointer represents an address, and it is pointing at an actual node that has a 0 and another address inside of it. All right, I've been talking for half an hour again. Take like 30 seconds, stand up and stretch. Jump up and down, scream if you need to. All right, welcome back. Welcome back. Okay, here we are. We've declared an address of things. If we follow that address, we end up at an actual node, and it has some values in it, and they're currently 0. That's not what we want them to be. We want them to actually have real values in there, particularly the integer. So how do we set this integer value inside there? We have to do what? We have to call the set data, but on what? Star what? Yes. So we do star head. What does this do? If we say star head, it says, look at this, it says, look at the address head, dereference it, which means go there, and when we get there, we actually have a node object. How do we set the value inside a node object? Set data. So we do dot set data. And what number do we want this one to be? Okay. So last time when we had all 3 up there, we had 7, 11, and 4. I'm going to cheat. And I'm going to cheat, and I'm going to do things the easy way. How many of you like doing things easy way? Absolutely. So we're going to put the last one on first. Okay? We're going to put the last one on first. The reason we're going to do this is imagine that you had all your children in alphabetical order and you wanted to hold their hands, right? If you held the hand of the first child alphabetically, then you would have to get the second child and like place them, and then the third child and place them, and then the fourth, and it would get longer and longer each time. If you cheat and you put the last child first, you can put the second to last child, have them hold hands and hold their hands, and now they are in order. And you can just kind of keep putting things on the front of the list, and as the list gets longer and longer, it's already in order instead of having to do things. Did that sort of make sense? Right? So it's easier to add things to the front of a linked list than it is to add things to the end of a linked list. You can ask. Okay. So you can just, it's easier to add things to the front of the list than it is to the back of the list. So we're just going to add things to the front of the list. Okay? So head set data 4. What that means is go down here and set this to 4. There we go, and this thing is still null, and we're kind of good. Okay? So now we are pointing at something that's 4. Yep. Yeah, you could do like star head dot set subject ID and things like that. When you get to it, you'll see. So we'll have a little more practice with this before then. So the project 5 is, the code's written. I haven't actually written the assignment. We'll have it on Wednesday for you. So you have something to do over Thanksgiving, because I know that'll be boring otherwise. Okay, so now what we want to do is we want to add another node in here, right? And what other node do we want to add in here? That didn't work. Uh-oh, now I'm confused. Let's see. Okay, we want to add another node in here. And the one we want to add will look like this. And we're going to stick it at the front. And we're going to give it a value. What value do you want this one to have? 11 is what we had before. So we're going to do this. We're going to create a new node with 11, and then we're going to link it into the right spot. Okay. How do we create a new node that has the value 11 in it? There we go. Is that it? All right, here's what we're going to do. We are going to make this new node be the head of the list. But we have to be very careful. What happens if we do this? All right, so if we said head equals new node because we wanted to create a new node, here's what would happen. Head would now point at this new node, and nothing would ever point at this node. It would be lost, right? Because we had this, right? This is what we had, and if we said head equals new node, then we get this node back, and head is pointing at this node, and what's pointing at the node that has 4 in it? Nothing. Imagine this. Imagine you had your string with your bottle that was in the water, and then all of a sudden you tied that string to a different bottle. What happened to the first bottle? What? What did you say? That's the perfect answer. I didn't know who said it. It floats away. It's gone. You have lost it. It's gone forever. You cannot get it back. So here is the danger of working with pointers. We have to be really, really careful never to lose track of one of the things that we created. Because if we lose track of it, it is gone. And you cannot get it back. You can't get it back because you no longer know what its address is. And you are sad. You want to pretend to be sad? Just for me? Thank you. Yes, it's gone forever. Once you no longer have a pointer to it, it's gone. This is a bad thing. It is called a memory leak. And once you've lost memory like this, it is just gums up your computer memory. Yeah. Nope. Nope. Not. It's gone. It's gone. Yeah. Nope. The compiler's like, all right, you want to cast that into this depth of space? That's up to you, man. Enjoy. Have a nice day. Whatever you like. The compiler is stupid, right? Computers are, that's not the word we use. That's rude. That's the S word according to my 6-year-old. Computers are dumb, but they're dumb very, very fast. If you would like to no longer keep track of where that particular node is, that is entirely up to you. You are welcome to not keep track of it. That's fine. It's just you're never going to get it back again. So we have to be careful, okay? We have to be careful while we're creating things. So let me show you what we're going to do here. What we're going to do is we are going to create another one of these pointers, okay? And what we're going to do is we're going to name it something different. Like in this case, we will call it temp. We're going to create some temporary pointer just to hold on to this thing, okay? So it doesn't get lost. Because you always have to have a pointer or some chain of pointers that get you where you want to go, or you will lose things. Everybody with me on this? Losing things is bad. Anybody, I mean, you're all old, young now, not old. Anybody ever heard of an operating system called Windows 95? Maybe you had it as a kid. When Windows 95 launched, they had a linked list in there. It was a linked list that kept track of every single program the computer was running. So there was a linked list that was like, here's the first program, here's the second. Their linked list had a bug in it. And what happened is when you closed a program, it unlinked the entry but did not delete it. It didn't go away. So you could crash your computer just by opening and closing programs, because what would happen is the memory would fill up with all these blocks that were keeping track of programs that were no longer running, and then your computer would crash. Because they made a mistake in something that we were teaching in Computer Science 1. Okay? So, don't make operating systems crash. Okay? So, you gotta always keep track of where things are. So what we're going to do is we're going to create some sort of temporary thing right here, temp, and that will keep track of our new node. So if we want to keep track of that, instead of using head, we will do this. Node star temp equals new node. So now we have created that new node. What value do we want to have in there? What did we say? Dereference temp and set the data to 11. So now we are at the point where we have exactly this picture. We have a head that points at 4, temp points at 11. Now, how do we link these things together? Yeah, you have a question? You're getting a compiler? Oh, okay. Okay. So I'm concealing some stuff from you. Yeah. So you have to put parentheses around it to use it that way. But we'll fix that in a minute, okay? Sorry about that. Okay. So what this says is get head, dereference it. We have to put parentheses around it so that happens first, and then we can set the data. So once again, here we are at this picture. We have two things. How do we link these two things together? Yeah. Okay, well we're going to put temp first and head second. So we're going to do it kind of the other way around. So here's what we're going to do. We're going to say star temp dot set data. And what are we going to set it to? Set data, set next node. And what are we going to set it to? The address of head, which is literally just head. Because head stores an address. We know that because there's a star and a node in front of it. Yep. Yes, new node just gives you an address. Because we don't have a name, that's all. That's the only thing we have to get a hold of that. So we do this, we do star temp set next node head, and here's what happens. Star temp set next node head, like that. So it's pointing there, just like that. But guess what? This is also still pointing there. So both things point at the same thing. So we said star temp set next node head, so that points at node, but star node head also still points at that one. Okay. Everybody with me? So here's what we did. We said star temp, dereference temp, set next node to head. Head is just an address. So we say star temp, dereference temp. So we end up at this thing here. And then we say set next node head. So it points at the same thing head is pointing at. Okay. Everybody with me on that? Silence is assent. You owe me $20. Yes. There's no vector. Don't even think. Don't compare this to vectors. Okay. Vectors use pointers, but vectors do not use pointers this way. Yeah. So yes, sir. We could, but what we want to do is really change head to point at the head of the list. Because is head pointing at the first thing on the list now? No, it's pointing at the second. How do we set it to point at the first thing? What? Make it equal to what? Make it equal to temp. Exactly. So here's literally how we change it. So I'm going to annotate this, okay? So create the first node. Yeah. Okay, so make a new node and have temp point at it. Then set the data. And then finally, here's what we do. That's it. Head equals temp. And so what head equals temp does is this. It says head currently is an address of this node that has 4. Temp currently is the address of the node, the thing that has 11. If you say head equals temp, it just goes bloop. And now head is pointing at the first thing on the list. Okay. Yes? Yes, each one of these boxes is a node, and each one of these arrows is something that points at a node. Okay? Yep. I don't know. I mean, temp, you have extra things that point to it. It's not a problem having multiple things that point to it, but it's a problem having nothing that points to it. So, okay. Go forth. Hopefully I'll see some of you on Wednesday. We will continue on from here. This stuff looks horrible, but didn't other things look horrible earlier in the semester too? Yeah, but you don't understand them because you haven't used them yet.